Hi everyone, today I would like to talk about radicals and rational expression. So let's review what we learned last time. We have learned about a square or a power of something. Like for example, is a square equal a times a to power 1 can be equal a to power 0 equal 1. And a to power negative of 1 gonna give me 1. I flip a become the bottom, so top gonna be equal 1 over a to power 1, which is a. Similarly, I have a to power negative 2 will give me 1 on the top, and bottom gonna be equal a to power 2. Okay, so you gonna think about if the power become at a fraction number. That's the reason why, for example, a to power 1 half and a to power 1/3. And that is the reason why today we learn about radical and rational expression. So in here is like a to power 1 half will can be written as square root of a, or I say like the root of a with the index equal to, and since we don't wanna normally we don't wanna write the index 2, and we just have square root of a without write down 2 or a hidden number 2 here. Alright, similarly a to the power 1/3 will be equal the root of a to power to the index 3, or someone call cube root a. Okay, for this one we cannot take away number 3. Okay, so now come back with the formula, general formula of the radicals. In here, everything when we call a radical expression. Okay. And the symbol here is called radical. And a here is a radicand. It's called radicand. Okay. And the b here is the index of the radical. So it's called index. Okay. So let's have some example. A square root of 25 equal, is that going to be equal positive and negative 5? Because I know that 5 positive 5 square equal 25, and negative 5 square also equal 25. So is that gonna give me square root 25 will equal positive and negative 5? But actually the answer is no. Because remember this, the square root, or a root of an even index will always give me the positive output or the positive number. So that is the reason why square root of 25 equal 5. Okay, so it will never become negative 5. Okay, so now what about square root of 16? Okay, so I'm gonna simplify the radical inside, which is square root of 16 first. The square root of 16 will give me 4, not negative 4, okay? And then now square root of 4 will give me 2, okay? What about square root of 49? I'm gonna have square root of 49 equal 7, and subtract for square root of 81. So I'm gonna subtract for square root of 81 equal 9. This give me negative 2. Okay. Now a square root of 25 plus 144. Okay. I will consider this square root as a grouping symbol. So then that is the reason why I have to do the addition inside of the grouping first. So this give me 169. Okay, 25 plus 144 gonna be 169. And this gonna be equal, okay, what is gonna be equal? I know that's equal 13 times 13. You're gonna try, but since this is 2 copy of number 13, okay, that gonna give me 13 as the answer. Okay. Now, what about if I have a square root of a square? Is that going to be equal a? Okay, maybe you will think that. So, since I don't know about a, I don't know if it's a negative number or if it is a positive number. So, for example, if a equal, I say a number 1, right? So I have like square root of a of 1 square. Maybe I change it become number 2 better. Okay, so this gonna become square root of 4, and it will give me equal 2. Okay, so if a is a positive number, it's gonna be okay. So I let me write out it here as if a equal to, okay, so if a equal maybe negative 2, okay, so let's see. So I have square root of a negative 2 everything square will give me a square root of negative 2 square gonna give me 4, right? And square root of 4 still give me a number 2. So now a here equal negative 2, but the output will give me is a positive 2. So that is the reason why here, if I don't know a, and I just write out square root of a square, a will equal a will not correct. So I should write as, in order to make it always positive, I should give is an absolute value of a. Okay, let's talk about the product rules of radicals. Okay, so the product rule of radical is square root of a times b will equal square root of a times square root b. And if I want to simplify a square roots by using product rule, I'm gonna have 3 steps. First step is factor any perfect square. So you have to factor any perfect square from radical. Okay, and then you should write as a product of radical expression, and then you simplify it. So let's try example A. Square root of 300. Okay, so I'm gonna write I know that's 300 gonna be, maybe I'm gonna rewrite as 3 times 100. Oh, okay, look, 3 is okay, 3 is not a perfect square, 100 is a perfect square. So I'm gonna write as 3 times 10 square here. Is that okay? Yes. And then I just gonna using product rule here. Okay. So after step 1, I using step 2. Okay. I'm gonna have 3 times square root of 10 square, which is equal square root of 3 times 10. And let's make it look better as 10 times square root 3. Okay. So it's now becomes simplified. Let's go to problem B. I have 1 square root of 162 times A to the 5th and B to the 4. Okay. So okay. I have square root of 162. It's gonna be equal. What is equal? Let me try to. Since this is this is an even number, so I can divide by 2. So since I divide by 2, so I have 81 times 2. Okay. So 81, I know it is a perfect square. Okay. Now let's try to convert the A to a 5th here, become some perfect square. Okay. But A to a 5th, well, it's not a perfect square. But I can, using the product rule of the exponential, I split A to the power 4 times A. I split the A to the power 5th become A to the power 4 times A. Does that make sense? And then keep the B 4. Okay. Now I rewrite it as square root of 9 square times 2 times A square square. A to the power 4 become A square square times A times B. Okay, image square root should be longer. Square, everything square. Okay. Now all the perfect square can be simplified. That give me a square root of 9 square here, multiply with A square square here, B square square here. Okay, I split it, and the other square root gonna have all the one that cannot become a perfect square. So 2 and A. Okay. So now this 9 square become 9. This A square, B square, and square root of 2A. Okay. So that now it's simplified already. So now I'm gonna talk about quotient rule of radical. So the quotient rule is actually similar with product rule. You're just gonna split the top and bottom with both has the square root. But remember, the denominator cannot equal 0. Okay, so for example, square root of 5 over 36 will give me square root of 5 over square root 36. And I know that square root of 5 we cannot simplify, but square root of 36 can be written as 6, because 6 times 6 equals 36, and you can take away the square root. Okay, so come to the problem B here. Okay, if you see something like this, I prefer gonna rewrite it as the big square root first. So I'm gonna combine this. So both top and bottom have this because why? Okay, let me show you why. So I just rewrite everything here with the big radicals. Okay. So now I can see, oh, there is a y in the top and y in the bottom. So I can cancel this. And everything now inside of the radicals. So that is the reason why I can factor something between top and bottom and then cancel it. Okay, so let's try. So I have 234 gonna be equal 9 times 26. Okay, so this become 9 times 26. Okay, let me split x to the power 11, or actually, because using the quotient rule of the exponential, I can keep the base as x, same base, and the power become in the top, so top bottom. Alright, and divided by the bottom now still have 26, and the x here just come back in here already. Alright, so now 26 with 26 go away, and I will have it as let's divide it as 9 times x to the power 4, and this give me 3 times x to the power square, x square. And thank you very much for the watching. See you next time.